So 3, 2, 1, go. Welcome back, ladies and gentlemen. So we just went over the simple rotator script to control the camera and rotation based on the mouse. So the next thing I wanted to go over with you guys was the first-person character script, the one that actually lets you move and jump and all that good stuff. So under my scripts, let's create a new script called FPS Character, and open that bad boy up. Alright, so like before, let's start out with the variables that we're going to be creating. Alright, so with this one we're going to do something a little bit different. We want these variables to show up in the editor, but we don't want other classes to be able to modify them. We basically want to be able to quickly change things in the editor, but if another class has access to the first-person character, we don't want it to be able to manipulate the speed or anything like that. So what we're going to do is we're going to create our first variable called the run speed. So we'll make it a float, run speed, and we'll set it to 8. And so since it's private, it won't by default show up in the editor, but we can add an attribute to it to make sure it shows up there. So if we want to serialize and make a private variable show up in the editor, we go serialize field. Alright, so now if we go back to our first-person character, and we'll drag our FPS character on there, run speed will show up. And if we comment this out, it'll disappear because it's private, and the editor doesn't see it anymore. Right? So there we go. We got our run speed, which is obviously how fast the character is going to run. The next one we're going to create is going to be called Strafe Speed, which is how fast it moves from side to side. So just like before, we'll go serialize field, private, stupid IntelliSense, private float strafe speed, and we'll set that to 4. Alright, and the next on our list is going to be our jump power. So with our first-person character, we're going to be using a capsule collider and a rigid body instead of a character controller. The reason we're doing this is with the rigid body capsule collider combo, you can have your character run into an object that also has a rigid body, and it'll interact and it'll bounce around and stuff like that, where a character controller won't. You'd have to script that yourself. And also, character controllers, if you have a whole ton of them in your scene, let's say you had like 40 AI or something like that coming at you, and they all had character controllers, that is extremely expensive. Having them all grouped together and colliding with each other, it just tears your computer apart. I found that out the hard way. So we're using a rigid body and a character controller. So to make the person jump, we're going to be adding a force to the bottom of the character, and that's going to be in our variable called jump power. So once again, serialize field, serialize field, private float jump power, and we'll set that to 5 for now. Alright, the next is going to be a Boolean value that is called walk by default. Alright, serialize field, private bool walk by default equals true. Basically what we're going to use this for is to determine whether or not your character is going to be running by default or just walking. Alright. The next one is going to be another float. And just like before, serialized field, private float, walk speed. And we'll set that to 3. And our last one is going to be a class that we're going to create right afterwards. So go serialize field, private advanced settings, and we'll just call it advanced, and equals new advanced settings. And there's 2 news there, so we'll get rid of that. Alright, so this is red because this class doesn't actually exist yet, so we're going to create it inside the FPS character class. So this is what is called a nested class, and so in order to have access to this class, you need to have access to the first person character, or just the character class in general. So go public class advanced settings. Alright, and in here we're going to have 3 more variables. The one is going to be a float, so we're going to make a public float called gravity multiplier, and we'll just set it to 1 for now. We'll have another variable, and this is going to be a physic material, and this is going to be called 0 friction material, and another physic material, and this is going to be called high friction material. Now, what a physic material is basically just something that defines a surface of an object and the way it interacts with the physics engine. So with the physics materials, you can determine how bouncy a surface is going to be, the friction, whatever it's called, basically how high the friction is going to be on a surface, and a whole bunch of other properties, and how basically any other object that has like a rigid body or anything attached to it, when it hits that surface with a physics material on it, it's going to bounce differently than a surface without a physics material or a completely different physics material. So it just lets you determine how bouncy something is going to be, or it just gives you more control over how objects interact with each other. That's the easiest way to explain it. Alright, so if we go back into the editor and we check out our FPS character, we're going to notice that our advanced settings isn't showing up, even though we put the serialized field there. And the reason for that is because this is a separate class, and Unity doesn't really know what to do with it yet. So in order to make sure that the editor can create a little inspector for it, we need to add another attribute to this class called, and it's in the system library, so system dot and serializable. Alright, so this tells Unity that this class can be serialized and usable within the editor. So now that we have that attribute, the advanced shows up here, and we can set the physics materials and the gravity multiplier. Alright, and we're almost done with our variables. We still have a few more to go. We're going to create a private capsule collider, and we're not going to put the serialized field attribute to this one because we don't want to show it in the editor. It's not really necessary, and we'll just call it capsule. Alright, and we'll create another variable, and this is going to be a const or a constant value. Float jump ray length equals 0.7. So basically what this is for is when we jump, we're going to be shooting a ray downwards, and it's going to determine whether or not we're landed on the ground or not. Okay. And we're going to create a public bool called grounded. And this is actually going to be a property instead of a field. And the difference between a property and a field is a field is just a plain old variable. You can assign it or use it however you want. A property is kind of like a wrapper around it. If you've done like C or C++ or anything like that, you'll know this by called getters and setters, specific methods to do things to a variable that you would normally need to create another method for. This is kind of just an easy way to do that. So I'll just finish the property and I'll tell you what it's doing. So we'll go get and private set. Alright, so what the heck is this thing meaning? Basically, this allows you to get the value of grounded from any class you want to, but you can only set it within this class itself. Alright? So any other value can get whether or not the object's grounded, but if you try and set the value of grounded from any other class, you'll get an error saying that it's either not defined or it's private, and you can't do that. But in this class itself, you can set it to whatever you want. Alright, and there is one more variable, and this is going to be a vector2, and it's going to be called input, and that's going to be basically us grabbing mouse position and that kind of thing. Alrighty, no, not mouse position. Yeah, you'll see. Anyways, so now that we have all of our variables here defined, and for the most part we know what we want to do with them, let's start with our functions. So our first one is going to be the awake function. So as soon as this object is entering the scene, we are going to assign the capsule. So collider as capsule collider. And basically what this is doing is going to grab the collider that is attached to this object and cast it as a capsule collider, and keep it in this value. Now if we didn't have a capsule collider and we had a box collider or a mesh collider instead, this would return null, and if we tried using it anywhere else, it would just give us null errors. So have to keep that in mind. Alright, and we're going to set the value of grounded to true. Alright, now the rest of this class is basically going to be in the fixed update function. So we've seen the awake function, the start function, and the update function, and we know what those do. Awake is as soon as this object enters the scene, this happens. Start happens shortly after that, and update is what happens every single frame. So what does fixed update do? Fixed update is the physics version of the update class. Physics happens a set amount of times every second, no matter what is happening. Update kind of varies depending on the frame rate, but fixed update, if you set it to 50, it'll run 50 times a second. Unless, of course, what you're doing in that takes longer than the allotted time, then you'll get stuttering. But no matter if what you do takes 0.0001 seconds, it'll wait until the next update, fixed update time, and then start doing the fixed update method again. Whereas update, where as soon as it's done, it waits till the next frame, does it again, waits till the next frame. So what happens in the fixed update might happen twice a frame, or it might happen once every 3 frames. It depends on what you've set that value to and how quickly your actual frame rate is. Alright, so in order to get into the fixed update function, go void fixed update, and there you go. Basically, anytime you're trying to modify a rigid body or anything like that, you pretty much want to do it in the fixed update. If you do it outside, for the most part it'll still work, but you might get weird things going on. Like I said, with fixed update happening at a consistent time no matter what, and update being variable, you can get weird issues where a rigid body or something that is controlled by physics acting odd if you try modifying things outside of the fixed update. So, yeah. Anyways, what we're going to do is create a variable called walk or run, and it's going to be getting that value from the input class .getKey. So we're going to be getting a key from the keyboard, and keycode.left shift. Alright, so if you hold down the shift, walk or run will be set to true, and if you release it, it'll be set to false. Alright, now we're going to set the speed that you're going to be running, and this is going to be using something called the Ternary Operator. And what the Ternary Operator is kind of the equivalent to an if statement, where if a condition is true, you do something, and if it's not true, you do something else. And you use it by using the question mark key. Alright, so here's what we're going to do. I'll type it out, and then I'll explain to you what is going on. So walk by default, question mark, in brackets, walk or run, question mark, run speed, colon, walk speed, colon, brackets, walk or run, question mark, walk speed, run speed, and that needs to be a colon. Alright, so what does that even mean? Walk by default, question mark, walk or run, question mark, blah blah blah. Alright, now the way the ternary operator works, I'll just type it out right here, is going to be some condition which is going to return true or false, question mark. If it's true, do true, if I could spell, and if it's false, after the semicolon, do false. Alright, so if the condition is true, you do what's on the left hand side of the colon, and if it's false, you do the right hand side of the colon. So walk by default is a Boolean value, and depending on what we set in the editor, it defaults to true. So if it's true, we're going to be doing this. Alright, and we're putting another ternary operator here. And here's where we determine what the speed is going to be. So if this is true, we check and see what walk or run is. If walk or run is true, we return the run speed. But if walk or run is false, we return the walk speed. Alright? So, walk by default is true. If walk or run is true, if we're holding down the left shift key, we want the guy to run. If it's not held down, we want him to walk. Now if walk by default was false, that means we want to run by default. So when we hold the shift key, we're going to be walking instead. And if it's released, we're going to be running. Does that make sense? I hope so. Alright. So now that we have our running speed, we are going to use create a ray, because we're going to be doing some ray casting. So ray equals new ray. We're going to take our current position, so transform.position, and negative transform.up. Right, so what this does, oh, not the class, we want our transform. Alright, so what this does is it takes the transform's current rotation and takes its up value and flips it upside down. And so we're going to be taking a ray from our position straight down from whatever our rotation is. So if we were like flipped on our side, the ray would be still downwards relative to us, so it would be off to the side. Alright, so it's basically just locally power down. Alrighty, now what we're going to do is check or create an if statement, and if we are grounded or our rigid body dot velocity dot y is less than 0.1. So if we're grounded, or we're really close to being grounded, or we're just, our movement in the up and down direction is really low, we are going to create an array of raycast hits. So this is going to be information received by a raycast, and we're just going to call it hits equals physics dot raycast all, and we're going to pass in the ray that we just created, our capsule height, capsule dot height times our jump ray length. Alright, so this is going to be sending a raycast downwards, the height of our capsule times the ray length, which is 0.7. So if our character's here, it's going to send a raycast, a little bit downwards, and it's going to return every single thing that raycast hit. Alright, now we're going to create a variable, a float variable called nearest, and we're going to set that to float.infinity. Oh, infinity. Positive infinity. There we go. Alright. And we're going to set grounded to false. Alright. Now we're going to do a for loop. So for int I, create a variable called I and set it to 0. Loop while I is less than the hits.length, and increase I by 1 every single time. Alright. Now if, alright, so in this if statement we're going to check if the collider that the raycast hit is a trigger. So if hits I dot collider dot is trigger. Alright, so as long as the trigger, or the collider, is not a trigger, and hits I dot distance is less than nearest. Alright, so as long as the collider is not a trigger and it is closer than the nearest value, grounded is equal to true, and nearest is equal to hits I dot distance. Alright, so what we're going to do is we're going to set grounded to true, and we're going to decrease the value of nearest to whatever the distance is. So basically what this is going to do is it's going to get the distance to the closest object the closest object to your character that the raycast hit. Alright, now, alright, give me 1 second. I want to change the way this looks. My style, apply. That's better. Alright, so we're getting our running speed. We're casting our ray to see if our dude's grounded to the ground. Now we're going to be actually running around and all that good stuff. Alright, so float. Horizontal input is equal to input dot get axis, horizontal, and we'll do the same for vertical input. Vertical input is equal to input dot get axis, and we'll type in vertical. So this goes back to the input manager like we went over in the last video. So vertical input, and we created our vector2 up here, so we'll just assign the values there. So new vector2, horizontal input, vertical input, bam. Alright, now if input dot square magnitude is greater than 1, input dot normalize. Alright, so basically what we're doing is we're detecting to see how much input is being given to the player, and we're making sure that the speed is going to be consistent no matter what. So if we were using a thumbstick, for example, and we were going up all the way and to the left all the way, we would have the line from the center, which would be 0, to the point would be greater than 1, and how fast your dude is running would be a lot faster than it's supposed to be. So when we check this square magnitude, we're checking to see if that distance is going to be greater than 1, and if it is, we'll normalize it back to 1. That way, you know, everything's nice and consistent, and your guy's not suddenly sprinting diagonally, which doesn't even make sense. Alright. Now we're actually going to move around a little bit. So first we want to figure out how much we want to move and in which direction. So we're going to create a vector3 and call it desired move, and it's going to equal our transform dot forward times input dot y times speed, and we're going to add transform dot right plus input dot x times strafe speed. Alright, so we are running forward as fast as we're pushing up on the D-pad or W or whatever we set our movement key to, and we're moving to the right the amount that we're moving or setting on the input to the right. So if we move to the left, input.x is actually going to be negative, so we're going to run to the left, and same with transform.forward. If input.y is back, it's going to be negative, so we're going to be running backwards. Alright. Now, what we want to do is we want to preserve the current y velocity of the character. So let's say we're falling off a cliff and you hit forward. We want to save how fast you're moving downwards, because we don't want you to just be falling and then hit forward and completely stop and start running forwards and then start falling all over again. We want to make sure that you're slowly, the whole glide effect that you see in a lot of games where you can be falling and start moving around in midair. That's basically what this is doing. Otherwise, if we didn't, as you're falling, if you hit forward, you would start moving forward and start falling all over again, but starting from a speed of 0. So we need to make sure that we keep the velocity of you moving downwards, just for that specifically. So we're going to go float, and we'll call it YV for Y velocity, just short for that, equals rigid body dot velocity dot y. And we'll go create a boolean called did jump, and we will set it to the input manager's value, so input dot get button, and it's called jump. And like before in the input manager, we'll just quickly jump over there. There is a jump key and another jump, and horizontal and vertical, all that good stuff. Alright. Oh, thank you Unity for that error. It says I cannot, says operator plus cannot be applied to operands of type Unity Engine Editor vector 3 and float. And that's because this right here, I'm trying to add the right vector to the input, and we wanted to multiply that. Alright. Alright. Now, I'm going to create an if statement, and if we're grounded, so if we're touching the ground and your dude hit the jump key, we're going to set the Y velocity to add jump power, and we're going to set grounded to false. Alright, so for grounded, we're going to set the velocity up to whatever we set it to, which is 5. So he's going to jump up at a velocity of 5 meters per second. And alright, so rigid body dot velocity equals desired move plus vector 3 dot up times YV. Alright, so the desired move is going to be on the X and Z plane, you know, running to the right and forward and back, and we're going to add the up vector of your velocity. So if you're jumping or you're falling to your death into a pit of bears. Alright, and now we're going to add another if statement. If desired move dot magnitude is greater than 0, or you're not grounded, collider dot material is equal to advanced dot 0 friction material, and else do collider dot material is equal to advanced dot high friction material. Alright, so what we're doing is, if you're, you know, if we're not grounded, or we're running along, or if we're actually putting input into the key, so we're trying to run, or we're falling, we're going to set the material of our collider to the 0 friction material that we're going to set in the editor. And basically it's going to make sure that there's no friction applied to our collider and we can just, you know, glide along. But if we don't put any input in and we're hitting the ground, the guy's going to slide to the stop using our high friction material. Alright, and then we're going to add a force to the rigid body. Rigid body dot add force physics dot gravity times advanced dot gravity multiplier minus 1. Alright. Alright. So basically what we're doing here is, if we are setting a force, if we're not, okay, by default gravity multiplier is 1 and we're subtracting 1. You might be asking, why do we do that? We're adding a zeroed out force to the rigid body, that way it'll still interact with objects. If we're just setting the velocity, the rigid body is going to move, but it's not going to actually interact with anything unless you actually use the add force key. And that's going to tell it to that there's maybe a collider there that it needs to bounce off of. Otherwise, it'll just pass right on through it. That's what you need to watch for when you're manipulating rigid bodies. You need to make sure that you add a force, whether it's a zeroed out force or not. Something needs to be added to that rigid body so that it'll calculate, you know, whatever. Yeah, the gravity multiplier. So if we set this to, say, 1.1, it's going to add an additional force of gravity times 0.01. Right? That way it's going to fall just a little bit faster, and still, you know, work the same way. And if we set this to less than 1, gravity's going to be a little bit less than what it normally would be. So yeah, that's basically what that does. Now, if this worked, and it should have, we can go to our first-person character and set those friction materials wherever they are. Where are they? We'll just quickly go here. There we go. Alright, so 0 friction, bam! Max friction, bam! Alright, now if we hit play, we should be able to run around and skip and play. Alright, and if we hit space for jump, yay! Yay! If we hold shift for running, we're going to start running. Yay! Isn't that fancy? Oh, looks like that script is on. We'll turn that off to make sure our script is actually working right. Alright, and it still works. Yay! Yay! Alright, and just to test everything out, if we jump and try and jump again, it doesn't do it. And if we run and put everything off, your guy's, you know, halts to a stop as if he's sliding on a high friction material. And if we jump and let go, bam, nothing. Isn't that fancy? Oh my god. Alright, so we did the first person character, and next I want to take care of the head bob. So if I turn the head bob back on, as your guy runs, see the camera kind of acts a little bit differently. You get a little head bob while you're running, and as he's jumping up, it looks like the camera's kind of attached to a neck, and your dude just kind of ragdolling it while he's running. So we're going to add that in the next video. Because like I said in the last video, I don't want these videos to be too long, but I'm going to put them all up on the same day anyways, just so you guys have them there. And you can kind of reference an individual video instead of trying to skip through, you know, 2/3 of the video if you want to get to the last half. Right, so see you guys next time for that head bob script. So now this time I want to go over the head bob script that they have and kind of explain in detail what it's trying to do. And, you know, your guy ragdoll